video is going to help you solve rational inequalities. And we're going to use the method of plugging in test points to find the solutions to the inequalities. The directions say to solve the inequalities and to write the solution using interval notation. Example number 1, 2x plus 8 over x minus 3 is greater than 0. So the first thing that we need to do to solve these inequalities is we need to find our solutions for x. And we'll do that by setting our numerator and our denominator equal to 0 and solving for x. So my numerator is 2x plus 8, and I'll set that equal to 0, and x minus 3 is equal to 0. So when I solve the equation on the left, I would first subtract 8 from both sides to get 2x is equal to negative 8. And then I would divide by 2 on both sides to get x is equal to negative 4. So one of my solutions is negative 4. And the other equation, I just need to add 3 to both sides. So my solution is x is equal to 3. So now that I have my two solutions, I'm going to plot them on a number line. So I'll draw my number line. I'll put those two solutions there, negative 4 and 3. And now I'm going to pick test numbers from each interval. So first I'm going to look for a number that's to the left of negative 4. So I'll choose negative 5 to plug in. Then I'll choose a number that's between negative 4 and 3. I'll choose 0. And then I'll choose a number that's greater than 3. So I'll choose 4. Now I'm going to plug each one of these test points into the inequality, and I'm just going to see if I get a positive or a negative output. I only care about the sign. I don't really worry about what the number is, so I don't have to reduce any fractions. So plugging in negative 5 first. So we have 2 times negative 5 plus 8 over negative 5 minus 3. Well, 2 times negative 5 is negative 10, plus 8 is negative 2, and negative 5 minus 3 is negative 8. Well, when you have a fraction that has a negative in the numerator and a negative in the denominator, those two negatives make it a positive fraction. So the output for this first interval would be all positives. Now I'm going to plug in 0. So I have 2 times 0 plus 8 over 0 minus 3. Well, 0 plus 8 is 8, and 0 minus 3 is negative 3. This time I have one negative, and one negative means that the whole fraction's negative, so my middle interval gives me negative outputs. Now when I plug in 4, I have 2 times 4 plus 8 over 4 minus 3. Well, 2 times 4 is 8, plus 8 is 16, over 4 minus 3 is 1. So I have two positives, so of course my output would be positive. All right, now we know the outputs for each interval. So let's go back to our inequality. Our inequality says greater than 0. So I'm looking for the intervals where it's greater than 0. So my interval from negative infinity to negative 4, that far left interval, gives positive outputs. And then the far right interval from 3 to infinity gives positive outputs. So there's my shading of my intervals that satisfy the inequality. It's greater than, so I'd be using parentheses here. All right, so writing that in interval notation, it's from negative infinity to negative 4, and then 3 to infinity. All right, let's look at example number 2. This inequality is x minus 8 over 4x plus 4 less than or equal to 0. Because I have this equal to 0, I have to do something special at the end. And so we're going to talk about it at the end. Something a little bit different happens here. So first I'm going to find my solutions for x by setting the numerator and the denominator equal to 0. So I have x minus 8 is equal to 0, and 4x plus 4 is equal to 0. So when I add 8 to both sides, I get x is equal to 8. And then in the second equation, I would subtract 4 from both sides to get 4x is equal to negative 4. And then divide both sides by 4, so x is equal to negative 1. So keep in mind that if I were to plug negative 1 into my denominator, it would give me 0. Okay, so just remember that my denominator would be made 0 if x is equal to negative 1. We'll come back to that again. All right, so let's plot those points or those solutions on our number lines. We have negative 1 comes first and then 8. And let's pick our test digits. A number that is less than negative 1, I'll pick negative 2. A number between negative 1 and 8, I'll pick 0. And then greater than 8, I'll pick 9. All right, so now let's plug in those test numbers into our fraction. Okay, so let's plug in negative 2 into our fraction. So we have negative 2 minus 8 over 4 times negative 2 plus 4. So negative 2 minus 8 is negative 10. 4 times negative 2 is negative 8 plus 4 is negative 4. Okay, so we have these two negatives again that they're going to make a positive. So my first interval yields a positive number. All right, let's look at our second interval when we plug in 0. So 0 minus 8 over 4 times 0 plus 4. That's negative 8 over 4. I have one negative, so it's going to give me negative outputs. And then the last interval, we're going to plug in 9. So 9 minus 8 over 4 times 9 plus 4. So 9 minus 8 is 1. 4 times 9 is 36, plus 4 is 40. So two positive numbers will, of course, give me a positive output. Okay, so now let's go back and look at what our inequality and what we need to satisfy that inequality, whether we need negative outputs or positive outputs. So this inequality says less than or equal to 0. So less than means negative. So we're looking for our negative outputs, which happen to be in the middle. And we know because we have this equal to bar, we need to put a bracket. But this is where something different happens. Whenever you have that equal to bar, you have to be careful of the number that comes from the denominator. Because we can't equal equal negative 1 because it will make our denominator be 0. So at the number that comes from the denominator, you always, always, always have to put a parentheses. Whatever comes from the denominator will always have a parentheses because your denominator cannot equal 0. So if I plug in negative 1 into my denominator, it will give me 0, which makes a bust for the fraction. So the number that comes from the denominator always has to have a parentheses. But my numerator, it's okay to have a 0. So my numerator can have a bracket. So the solution then would be a parentheses, negative 1 to 8 with the bracket. So just be wary of whenever you have that equal to bar, you can't put the bracket on the number coming from the denominator. Okay, example number 3. We have negative x plus 4 over x squared minus 5x minus 6 greater than 0. Okay, so the same thing applies. We're going to set our numerator and our denominator equal to 0 and solve for x. So negative x plus 4 is equal to 0 and x squared minus 5x minus 6 is equal to 0. Well, in the first equation, instead of subtracting 4, you know what I'm going to do here? My x is negative, so I'm just going to add x to both sides. So I end up with 4 is equal to x, which of course means x is equal to 4. All right, my second equation is a quadratic equation, x squared minus 5x minus 6. Well, in order to solve this one, I have to factor it. So I'm going to have to do split b here. So factors of a times c, factors of -6 that give me -5. So that's going to be a 1 times -6 is -6, and 1 plus -6 is -5. So let me split b into a -6x and a positive 1x. Bring down my first term and my last term. And now I can do my grouping. The GCF of the first group is an x. That leaves me with x minus 6. I'll bring down the plus. The second group only shares a 1 in common, which leaves me with x minus 6. So I end up with x minus 6 times x plus 1 is equal to 0. And now when I set each factor to 0, my solutions for x are x is equal to 6 and x is equal to -1. All right, so this time we're going to have an extra number on our number line. But even though we have an extra number, doesn't mean we're going to do anything different. So I'm going to put -1 on the left, and then 4 and 6. And now I'm going to choose my test numbers. So something that's left of -1, I'll pick -2. Something between -1 and 4, I'll pick 0. Something between 4 and 6, I'll pick 5. And something that's greater than 6, I'll pick 7. So now I'm going to plug them into that polynomial. So I have to be careful because I have that negative in front of my x. So it's going to be negative and then -2 plus 4 over -2 squared minus 5 times -2 minus 6. Got to be careful because there's a lot of negatives here. So negative times -2 is a positive 2 plus 4 over -2 squared is 4. -5 times -2 is positive 10 minus 6. So my numerator gives me 6, and my denominator, 4 plus 10 is 14, minus 6 is 8. So both numbers are positive, so it's going to give me a positive output. All right, now let's plug in 0. So we have negative, and then 0 plus 4, all over 0 squared minus 5 times 0 minus 6. Okay, so I'm going to cancel out the things that 0 out. So I end up with 4 over -6. I have one negative, so that makes the whole fraction negative. So my second interval is negative. Now let's plug in 5. So we have negative and then 5 plus 4 over 5 squared minus 5 times 5 minus 6. So -5 plus 4 is -1 over 5 squared is 25 minus 25 minus 6. Well, the 25 minus 25, those cancel each other out and make 0. So we end up with -1 over -6. We have those two negatives. So two negatives make a positive. So this is a positive output. All right, now let's go to 7. So we have -7 plus 4 over 7 squared minus 5 times 7 minus 6. So negative 7 plus 4 is negative 3. And then in my denominator, I have 7 squared is 49 minus negative 5 times 7 is negative 35 minus 6. So 49 minus 35 is 14. 14 minus 6 is 8. So we end up with a negative over a positive. So this one is 1 negative, so it ends up being negative. All right, so now let's go and find out which intervals are going to satisfy our inequality. So our inequality says greater than 0. We don't have that equal to bar, so we don't have to worry about the denominator at all, because or the numerator. Everything's going to get a parentheses. Greater than 0 means I'm looking for positive outputs. So let's shade our positive outputs. So the interval on the far left is positive. The next interval is negative. The interval between 4 and 6 is also positive. And again, we're going to use parentheses here because we don't have that equal to bar. So let's write those intervals using interval notation. So we have negative infinity to negative 1, and then union 4 to 6. So all these two intervals will give me positive outputs. All right, our last example. Number 4, 3x plus 10 over x plus 2 less than x minus 8 over x plus 2. Okay, so if you look at this one, it looks very different than the other examples. Well, the reason is it's not set to 0. So that's the very first thing that we need to do is set this inequality equal to 0. So what I'm going to have to do, and this is a little tricky, is I'm going to have to move this fraction that's on the left, on the right, over to the left. So what I'm going to do is I'm going to subtract the whole fraction. So I'm going to put in parentheses around it and then put a negative on the outside. And then I'm going to do the same thing over on the right side. Excuse me, the left side. All right, and I'm going to take this very slowly so that I don't make any careless errors. So I didn't do anything to my first fraction on the left, so it's going to stay 3x plus 10 over x plus 2. And then I'm adding this negative fraction, negative x minus 8 over x plus 2. And now it's less than 0 because I zeroed it out. Okay, so now what I'm going to do is I'm going to take this negative and I'm going to do a sign changer to both terms in the numerator. Right, I'm distributing it to the numerator. That's where I'm going to put that negative. So my first fraction is 3x plus 10 over x plus 2. Then I'm going to add to it the fraction that is negative x plus 8 and then over x plus 2. So again, what I did was the sign changer to only the numerator. You can't pass it out in both places, and you don't want to mess with the denominator. And this is less than 0. All right, now the good news is that I have a common denominator. So you can always add fractions when you have a common denominator. The rule says that when you have a common denominator, you keep the denominator the same, x plus 2, and you add the numerators. So I'm going to add a 3x and a minus x together, and that's going to give me 2x because those are like terms. And then I'm going to add the 10 and the 8 to get 18. And now I have one fraction that's less than 0. Okay, so we had a lot more going on in that problem, but what we did was we just combined it into one fraction because it had a common denominator, and we took both terms from the numerator, we gave them the negative so that we could have one fraction with like terms in the numerator. All right, so now let's do what we did before, that it looks exactly like the previous examples. So we're going to set our numerator equal to 0 and our denominator equal to 0. And then we're going to solve for x. So I'd subtract 18 from both sides to get 2x is equal to negative 18, and divide by 2 to get x is equal to negative 9. And then in the second equation, I would just subtract 2 from both sides to get x is equal to negative 2. All right, so those are my two solutions that I'm going to put on my number line. All right, so let's pick our test numbers now from each interval. A number that's to the left of negative 9 would be negative 10. A number that's between negative 9 and negative 2, I'll just pick negative 8. So I'm picking on both sides of negative 9. Doesn't matter which number you pick in the middle interval. And a number that's greater than negative 2, that's where 0 belongs. It's greater than negative 10. So I'm going to pick 0 as my interval test number on the right. So what I'm going to do now is I'm going to plug them into this inequality that's set to less than 0. That's the one I want to use. I don't go back to the original. I go back to what I did when I combined the two fractions. All right, so let's plug that in. So it's going to be 2 times negative 10 plus 18 over negative 10 plus 8. 2 times negative 10 is negative 20 plus 10 is negative 2. Negative 10 plus 8 is negative 2. Two negatives in a fraction make it positive. So my first result is positive. All right, now let's plug in the negative 8. 2 times negative 8 plus 18 over negative 8. Oh, excuse me, that should have been a negative 10 plus 2. I'm sorry. It gives me a negative 8, negative 8, which still makes it positive. I apologize for that error. I think I was doing the math in my head, and so that's why I wrote the 8. So anyways, that's what I did wrong, but it's still a positive output, right? I wrote the problem wrong. On the second denominator, it's negative 8 plus 2. So that's going to be 2 times negative 8 is negative 16 plus 18 is 2. Negative 8 plus 2 is negative 6. I have one negative, so my output is negative for this interval. And then plugging in 0. So we have 2 times 0 plus 18 over 0 plus 2. Well, these 0 out, so I'm just left with positive 18 over positive 2. Two positives stay positive. All right, so let's go back to our inequality. It says less than 0. We don't have to worry. Both numbers are going to get parentheses. Less than 0 means negative number. So we're looking for our negative interval, which happens to be the center on this one. So I'm going to shade that. And then both get parentheses because there's no equal to bar. And my interval will be from negative 9 to negative 2. So here are the steps if you wanted to write them down. Step number 1 is make sure the inequality is set equal to 0. Step 2, solve for x by setting the numerator and denominator equal to 0. Plot solutions on a number line. Pick test numbers from each interval to determine the sign of the output. So we're going to plug those back into the fraction, and you only worry about the sign. Step 5, shade intervals that satisfy the inequality. If it's greater than 0 or greater than or equal to 0, it's positive. If it's less than 0 or less than or equal to 0, you're looking for negatives. Write solution using interval notation. And then also remember solutions for x from the denominator always use a parentheses.